In this video, we're going to do a couple examples where we're going to be using trigonometric identities and using a calculator for the second part. So in this first portion of our example, we have let theta be an angle in quadrant 2, such that the sine of theta equals 1/3, and we're going to be using trigonometric identities to find the cosine of theta and the tangent of theta. So we know that the sine of theta is 1/3, and that we're using trig identities. So what do we know? Well, if we're in the second quadrant, then we see that only our sine and cosecants will be positive. Everything else will be negative. So that tells us that our cosine of theta is going to be negative. So we know that the sine squared of theta plus the cosine squared of theta equals 1, and that is our trig identity. So we're trying to get the cosine of theta by itself. So we know that because the sine of theta is 1/3, and we're told that, we can plug in 1/3 into our equation here. And so we'll square that. And so now we'll subtract that to the other side, giving us the cosine squared of theta equals 1 minus 1/9. From there, we'll have the cosine squared of theta equals 8/9. We'll square root both sides. And that's going to give us the square root of 8 over the square root of 9, which is the square root of 8/3. Now, if we reduce the square root of 8 and make a factor tree, we see that we're going to have a pair of 2's that can come out, but a leftover 2 that stays in. So we'll have 2 radical 2/3. So here we have the cosine of theta equals the square root of 8/3, which simplifies to 2 radical 2/3. Now remember that our cosine is supposed to be negative because in the second quadrant, only sine and cosecant are going to be positive. So we have a negative 2 radical 2/3. For part B, we're asked to find the tangent of theta. Now we know that the tangent of theta is the sine of theta divided by the cosine of theta, and this is one of our trig identities. Well, we know that the sine of theta is 1/3, and we just found that the cosine of theta is negative 2 radical 2/3. So we're going to rewrite this so that we can see the keep, change, flipped aspect of our fraction divided by a fraction. Here, we're able to simplify this by crossing out our numerator and denominators that are shared, which is the 3, leaving us with a negative 1/2 radical 2. From there, we need to rationalize. So we'll multiply both our numerator and our denominator by the square root of 2, which is going to give us negative square root of 2 over 2 times 2, which is 4. So we have negative radical 2/4. So we have that the tangent of theta equals negative radical 2/4. Now when it comes to using a calculator, we'll evaluate it to 4 decimal places. For the trig functions, it's important to know when should you be using which mode, meaning should you be in degree mode or should you be in radian mode. So we're going to discuss that as we go through our 3 pieces. So for part A, it says to evaluate the cotangent of 410 degrees. Well, because that's in degrees, we want to be in degree mode. So you'll need to make sure that you select the degree mode in your calculator. You can do that by hitting the word mode on your calculator, like so. And I can arrow down and arrow over to the word degree, highlight it, so I'm going to hit enter, and that will put me into degree mode. Then, as I'm ready to go into my cotangent, so I'll quit out of that, and as I'm ready to go into my cotangent here, I have to remember that tangent is actually a reciprocal of tangent. So I have 1 divided by the tangent of 410, and that's what I'm going to enter into my calculator. So I'm going to have 1 divided by the tangent of 410. I'll hit enter, and I get 0.839099, so 0.8391 is what we will put for our answer. Now part B says the sine of -7. For this one, we want to be in radians. So again, we'll go to our mode, arrow down, highlight radians, and then plug it in. So we're looking for the sine of -7, and that's going to give us negative 0.656986, and that will round to negative 0.6570. For problem C, we have the secant of pi over 9. And pi over 9 is a radian, so we'll stay in radians. And remember that secant is the reciprocal of cosine. So we'll be putting in 1 divided by the cosine of pi over 9 into our calculator. So 1 divided by the cosine of pi over 9 into our calculator. And that gives us 1.064177, which is going to simplify to 1.0642. Now, an important little tidbit for when you are evaluating trig functions is being able to tell if they are even or odd, which isn't so much a help for the calculator as it is for other types of evaluations like what we did in the first part of our examples. So I just want to touch base and cover this really quickly. So it's being able to tell if we have even and an odd trig functions. So the cosine and secant functions are going to be considered even if we're able to say that the cosine of negative t equals the cosine of positive t, and that the secant of negative t equals the secant of positive t. And then our sine, cosecant, tangent, and cotangent functions are going to be considered odd if we say that the sine of negative t equals the negative sine of t, the cosecant of negative t equals the negative cosecant of t, the tangent of negative t equals the negative tangent of t, and the cotangent of negative t equals negative cotangent of t. Again, having them be even and odd is helpful for when we are dealing with evaluating trig functions and simplifying trig functions.